to change now the ISO value shown in vesta, you go to Objects, Properties, and then ISO surfaces. And then you get a little window with all the properties that you can and cannot change. You select your loaded ISO density value data. That is number 1 for me here. And then there's a input box labeled ISO surface level that you can change. So I changed that now to 0.4, and I confirm that, and you see my ISO density has almost vanished here, right? So I don't see any charge density here anymore, right? Where my hydrogens atom are, it's not. Because now I say that only plot that part where roughly half of my electrons are, and they are pretty localized, because they decay like this, right? Like this. So half is very near the center. And when I increase to larger and larger values, the expansion was very fast or rapid. So now I go to, let's say, roughly 10%, meaning I have 90% of my electrons inside that surface. Right? And you see that now that surface is a bit larger. Now I say, give me 99% of all the density. Pretty large, right? I can go like 1 promille. I confirm pressing enter, and it's getting bigger and bigger, right? And if you go closer and closer to 100%, you see I can get pretty big here. Let's see that the whole thing breaks down. So now something weird is happening. Do you see that that whole surface is not smooth anymore? And that is because we are looking now at very, very small values at the end of that exponential tail here. And sometimes we have numerical noise. We also have some approximations. We used an energy cutoff, right? Meaning that the sampling here is not that good. If you want a smoother surface, you probably first would start to increase the energy cutoff to very large values and try again. If that doesn't help, I would stop there and probably argue that there might be numerical noise in the calculation. And therefore I am like, okay, that's how good we can go. It's not that important anyhow at these large numbers, so I go to 0.7, that still looks a bit wiggly. So I go to 0.06, that looks pretty smooth. I'm happy there, and then I would say, okay, that is my density here, now containing almost all of the electrons. Now we can add the section again. We look at the section and you see that we have now the color bar again, showing that from the high intensity red to the low intensity blue, and at the very large region here, almost nothing is changing anymore, right? Because we are in this exponential region of the tail where even if you go to a larger percentage of the included electronic density, the absolute changes are actually pretty small in this region. Right, so for your lithium case, if you repeat that on some point, they definitely are going to merge. Okay, did you manage to do that too? Because sometimes when you go to more complicated cases, larger molecules, and you're interested in what is happening on a certain bond, right? What is the localization of electronic density? And you want to give a message, right? You need to sometimes select this value a bit more carefully, then be consistent on that value. If you once have decided on a value, don't switch it, right? because that would mislead the reader. Right? Sometimes you so like large density, then you show small density just because you change the isosurface level. That is misleading. Choose the same one in all your plots in one work, and then you can indicate changes on the density. And that is a parameter you need to can change. You need to understand that it represents the amount of included electrons, and then you can work with it. Okay. Right. So in any case, these large density values here of the isodensity surface are normally not used. Standard values. Let's put it back to standard. Is often 0.02. That is a pretty standard value. Right, and then it looks like that. Good. So